NASA gave an essential insight. Pluto isn't what you think. What is NASA suggesting here? Are they implying the most recent divulgences from the New Horizons space probe, which show that odd things are happening on Pluto's surface? One of the risky pictures indeed shows something that appears, by all accounts, to float across the outer layer of Pluto. This raises upsetting demands with respect to whether some sort of high-level dark life exists on this faraway world, or are we dealing with an easily recognizable geological trademark? Pluto might be almost nothing, yet the accounts it holds to tell are immense and stacked with shocks. At the point when Pluto's planetary status was repudiated in 2006, researchers were clueless about the information from the New Horizons probe, which just appeared at Pluto after years. From that point forward, we have realized that there is more to this smaller object than was typical. How did astronomers really come to deny this planet, which we have all in some way grown up with? Everything going on with a real planet had been like that after the discovery of various other small planets in the Kuiper belt. They reasoned that we truly required a breaking point for what is a planet and what is a dwarf planet or trans-Neptunian object. How did astronomers deny Pluto? It scored points for its size and round shape, yet the planet shares its orbit with several different things. The orbit is, therefore, not considered to be great, and this was the defense for why Pluto was not generally connected with the overview of the huge planets in the planetary system. Many people on Earth think this is a disgrace, and this decision by space experts caused dissatisfaction among people in general. Pluto, now not a planet, was a problematic thought for some. The fact that this little, insane planet has so many fans on Earth prompted letters of dissent to NASA from eminent experts who supported the minimization. Truth be told, even state-run organizations got letters from residents requesting Pluto to be a planet again. This planethood had been with us since the 1930s and was a significant part of a group of 9 planets. It was as though to advance this in 2015, when New Horizons sent us the first authentic picture. The Pluto Earth mover planet showed us its enchanting face. Imagine it was the first authentic picture of Pluto. If you've seen the planet on sheets or in school materials before, they were artistic portrayals, not real pictures. Pluto denied even the really certified pictures of Pluto from the Hubble telescope, a clearer viewpoint on its surface. In a way, New Horizons was permitted to photograph the little one as it truly is. Breathtaking, well-ordered, irrefutably rich, and with a heart. From that point forward, the planet on the outer edge of the solar system has gained a lot more fans, and maybe space professionals will change their perspectives one day and we will get Pluto back. The first certified pictures of Pluto took everyone's breath away. It was a cherished moment when the first information from the New Horizons probe arrived at mission headquarters in 2015. Everyone present knew that they were about to see a planet for the first time, one that everyone was somehow familiar with but had never seen up close. The computers on Earth assembled this hypnotizing picture from vast amounts of individual pieces and pixels. What the test uncovered about Pluto was a revelation that completely turned our understanding of this faraway planet on its head. Pluto is altogether more changed, fundamentally more planned, and basically more alive than planetary scientists had previously recognized. In addition, the little planet appeared to be covered in picturesque features and perhaps even much more natural idiosyncrasies no one had expected. With each new piece that New Horizons granted, the dim, bewildering world in the darkness of the Kuiper belt transformed into a significant thing that showed such an abundance of life that it blew experts' minds. More and more bewildering topographical miracles opened up before the analysts. Instead of the ordinary freezing and cratered no-man's land, Pluto turned out to be a no-man's land, an interesting spot with great bits of ice, deep canyons, and smooth, cold surfaces. It required a very long time for the endless estimation data, photographs, and discoveries to make the long journey from Pluto to Earth. Since 2015, we have been astonished at least a time or two with new captivating perspectives about Pluto. Who is that walking on Pluto's surface? It's amazing. This moving picture flowed in the media in 2016. Anyway, what could you anytime see? Here it seems as though an individual is walking across a surprising honeycomb-shaped snow drift. You can truly see ice honeycomb landforms here, but not in any way like on Earth. These frozen surfaces are not made of water but of nitrogen and methane. Scientists recognized the astounding thing as a dirty piece of ice, which appears to be floating over the surface of the ice-covered plain. The huge block of ice is the best bet, also made of incredibly strong nitrogen. These peculiar-looking landforms revealed something very remarkable to prepared experts. They now believe that there is a nitrogen supply several kilometers under Pluto's surface, where the solid blocks form topographical developments. The inside of the planet pushes these blocks upwards, making the honeycombs and fields like the seemingly wandering mountains. This points to a warm center of the planet, and this discovery is a clue that could have wide implications for how we might interpret Pluto. Pluto is definitely more unique than previously recognized. Land development from heat, along with changes in surface designs, shows a kind of aliveness that suggests we have underrated Pluto. This smaller object shows some thought as well as fire in it, and that would for sure suggest that there are pockets of fluid inside Pluto that look like seas or magma. The geology team of the New Horizons mission, led by William McKinnon, even compared the inner existence of the small planet to an astonishingly large scale, like Hudson Bay in Canada. Virtual experiences showed that this striking scene developed over centuries and is still incredibly unique today. Could you ever see the particular X on the right beneath the chilly mass? This plan was probably made by sublimation, a process in which a substance changes directly from a solid to a vaporous state, and the fluid stage vanishes. These cycles happen due to the extreme temperatures on Pluto, confounding geographical cycles and ecological peculiarities in a dead world. Christmas in the snow on Pluto. Does that sound crazy to you? Well, it's a reality. Pluto truly is a mystery. The New Horizons mission uncovered intriguing bits of the environment and periodic changes on this planet, Pluto, which orbits in the cold, far-off regions of the Kuiper Belt. Pluto's environment, a thin layer of nitrogen, methane, and carbon monoxide, changes drastically depending on how close or far Pluto is from the Sun. The changes affect the climate as well as the surface states of the dwarf planet. One particularly brilliant aspect of the natural factors is snow on Pluto. This contains mostly frozen nitrogen and methane, unlike Earth, where snow forms only from water. The very low temperatures on Pluto cause the more volatile gases, nitrogen and methane, to gather and fall as unique snow. All of these interactions shape and stimulate Pluto's surface by covering the landscape with new deposits. These disturbances drive other geographical developments, like cold progression and maybe even cryovolcanic cycles. The New Horizons research also showed that these seasonal cycles are closely tied to barometric pressure. When Pluto is closest to the Sun, the small light is enough to warm up the dwarf planet's atmosphere, causing it to expand slightly and rise. When Pluto moves away from the Sun again, the atmosphere freezes and sinks back to the surface. This quirk leads to a striking inconsistency. When Pluto's atmosphere condenses, it could literally snow, with snow made of nitrogen and methane. The variations in surface brightness and the distribution of cold deposits further suggest that nearly all surface features and scenes on Pluto are linked with these environmental cycles. Since Pluto's mountains are not made of rock, but of ice, which is very adaptable on this world, the entire surface moves considerably more than that of our Earth. For instance, what does Pluto's heart contain? Who would have guessed that Pluto's heart isn't just a pretty, warm imprint? Despite its prominent appearance, this area is also one of the most surprising regions on Pluto. Previously considered Sputnik Planitia, the Sputnik Planitia area is named after the first artificial satellite, Sputnik 1, which the Soviet Union sent into space in 1957. This massive heart-shaped ice surface stretches across an area of about 1,000 kilometers and consists mainly of nitrogen ice, with hints of frozen methane and carbon monoxide. The bright, almost perfect surface of Sputnik Planitia forms a sharp contrast to the darker, more complicated regions around it. Geographically, Sputnik Planitia is a huge impact structure that was probably later altered by volcanic cycles, not by the usual volcanic activity on Earth, where magma rises from the planet's interior. Cryovolcanism on Pluto involves cold materials rising from the dwarf planet's interior to the surface. The heat sources deep inside Pluto cause nitrogen and other volatile substances to warm up and push upwards, where they freeze and form unique formations like this one. Sputnik Planitia is remarkably flat, which leads scientists to conclude that the cold surface is continually renewed by internal cycles. it's likely convection processes inside the ice sheet that form these landscapes. Scientists expect that there might be a range of liquid water under the smooth ice sheet of Sputnik Planitia, which is kept liquid by the heat inside Pluto. Scientists wonder whether forms of life can exist in the subglacial sea. Yet, it's not entirely impossible. Charon asterisk, what role does Charon play? What scarcely anybody knew is that before New Horizons mission, Pluto had its own moon, and not just one. Charon is Pluto's largest moon, and was discovered in 1978 by the American astronomer James Christie. Charon is very large in comparison with Pluto, with a diameter about half of Pluto's. This has led to a significant connection between Pluto and Charon, where the two objects are tidally locked, meaning that Pluto and Charon always show the same side to each other. Charon's surface is also incredibly unique compared to Pluto's, with enormous crevasses and huge impact craters. Scientists believe that Pluto and Charon have been exchanging materials in the form of comet-like objects. Pluto, once regarded as the 9th planet in our solar system, has long captured the imagination of astronomers, scientists, and the general public alike. Discovered in 1930 by astronomer Clyde Tombaugh, it stood as a symbol of planetary exploration and mystery. However, in 2006, the International Astronomical Union, IAU, reclassified Pluto as a dwarf planet, sparking controversy and debate. Despite this change, Pluto continued to intrigue scientists and enthusiasts who wanted to understand more about this distant object on the edge of our solar system. NASA's recent warnings about Pluto's true nature, embodied in the phrase, "Pluto is not what you think," are now drawing renewed attention to the enigmatic world. This phrase, often coupled with compelling statements about the dwarf planet's complexity and significance, hints at revelations that have emerged through the latest missions, observations, and research. While many aspects of Pluto's makeup have been confirmed over the years, there remains an ever-growing understanding of its mysteries that complicate our assumptions. Through NASA's exploration of Pluto, particularly by the New Horizons mission, we are learning more than ever before. In this article, we will explore the latest findings, scientific advancements, and the evolving perceptions of Pluto as a planetary body. From its controversial reclassification as a dwarf planet to the current revelations about its composition, atmosphere, and potential for future exploration, we will examine how NASA's research is continuing to reshape our understanding of this icy world at the far reaches of our solar system. The reclassification of Pluto. Pluto was discovered in 1930 by Clyde Tombaugh at the Lowell Observatory in Arizona. For more than 70 years, it was classified as the 9th planet of the solar system. It was small, icy, and located at the farthest reaches of the known solar system, but its designation as a planet was never seriously questioned. However, the debate surrounding Pluto's status began to heat up during the 1990s, as astronomers discovered other objects beyond Pluto in the Kuiper Belt, a vast region of icy bodies extending beyond the orbit of Neptune. One of the key objects was Eris, a distant object that was discovered in 2005 and is similar in size to Pluto. As more of these objects were discovered, scientists began to reconsider Pluto's place in the solar system. In 2006, the International Astronomical Union, IAU, officially redefined what it means to be a planet. According to the new criteria for an object to be considered a planet, it must orbit the Sun, be spherical in shape due to its own gravity, have cleared its orbit of other debris. Pluto, however, did not meet the third criterion. While it orbits the Sun and is spherical in shape, it shares its orbit with other objects in the Kuiper Belt. As a result, the IAU reclassified Pluto as a dwarf planet. This decision was met with disappointment by many, but it also marked the beginning of a new era of exploration and understanding for Pluto. Despite its new status, Pluto remained an object of fascination. It was still an unexplored world, located more than 3.6 billion miles from the Earth. While Pluto was no longer considered the 9th planet, it was still a key target for scientific study, especially as new technology and spacecraft began to venture farther out into the solar system. NASA's New Horizons mission. The most significant event in the exploration of Pluto came in 2015 with the arrival of NASA's New Horizons spacecraft. Launched in January 2006, New Horizons was designed to perform a flyby of Pluto, providing the first close-up images and data of the dwarf planet. The spacecraft traveled more than 3 billion miles over the course of 9.5 years, finally reaching Pluto in July 2015. New Horizons' flyby of Pluto marked the first time a spacecraft had visited the dwarf planet, and it delivered a wealth of data that would forever change our understanding of this distant world. The images and measurements captured by New Horizons revealed stunning details about Pluto's surface, atmosphere, and moons. Perhaps most notably, it showed that Pluto was far more complex and dynamic than scientists had previously imagined. Pluto's surface, a world of surprises. One of the first and most striking surprises from New Horizons' flyby was the unexpected diversity of Pluto's surface. Prior to the mission, scientists had assumed that Pluto's surface would be uniform and relatively static, given its remote location and low temperatures. However, New Horizons revealed a surface that was anything but dull. The spacecraft captured breathtaking images of vast plains, towering mountains, and deep valleys. One of the most famous images from the mission shows a large heart-shaped region on Pluto's surface, now known as the Tombaugh Regio, after the discoverer of Pluto. This region contains a vast plain of nitrogen ice, which is thought to be one of the youngest surfaces on Pluto. The relatively smooth and featureless nature of this area suggests that it has been resurfaced relatively recently in geological terms, possibly due to a process of cryovolcanism or ice volcanism which had never been seen on Pluto before. Other regions of Pluto's surface, such as the mountainous areas of the Norgay Montes and Parker Montes, revealed structures that are likely formed from water ice, which is much harder than the surrounding nitrogen ice. These mountains rise as high as 11,000 feet and indicate that Pluto's internal structure may be much more complex than previously believed. In addition to the unexpected geological features, New Horizons revealed that Pluto has an active atmosphere that is constantly being replenished and modified by processes within the planet. This atmosphere is thin, composed primarily of nitrogen, with traces of methane and carbon monoxide. The images revealed evidence of haze layers, which could play a role in redistributing gases within the atmosphere, further complicating scientists' understanding of the dwarf planet's behavior. The atmosphere, a dynamic system. Pluto's atmosphere has proven to be one of the most intriguing aspects of the dwarf planet. When New Horizons flew by Pluto, scientists were surprised to find that its atmosphere was not only more active than expected, but also surprisingly complex. The atmosphere, which is composed mostly of nitrogen with smaller amounts of methane and carbon monoxide, is thin, but it plays an important role in the planet's climate and surface processes. The atmosphere is constantly being replenished from Pluto's surface, where nitrogen ice sublimates, turns into gas, and enters the atmosphere. The low temperatures on Pluto, around -375 degrees Fahrenheit, -225 degrees Celsius, mean that this atmosphere is constantly freezing out and refreezing, creating a dynamic exchange between the surface and the atmosphere. This exchange has led to the formation of hazes, which were detected during the New Horizons flyby. Scientists have also found that Pluto's atmosphere exhibits seasonal changes. Like Earth, Pluto experiences a form of seasonality, with its tilt causing different regions of the dwarf planet to receive varying amounts of sunlight. This affects the atmosphere, leading to changes in the density and structure of the hazes. These seasonal variations are thought to be driven by the planet's long orbital period. Pluto takes 248 years to complete one orbit around the Sun.